The second video is going to explain how to solve distance problems by solving rational equations. So the big thing in each of these problems is going to be the formula distance equals rate times time. Distance equals rate times time. All right, and then also taking or drawing a picture of each situation can be very helpful. So in this first problem, it says Sandra is rowing a canoe on Stanhope Lake. Her rate in still water is 6 miles per hour. It takes Sandra 3 hours to travel 10 miles round trip. Assuming Sandra rowed at a constant rate of speed, determine the rate of current. All right, so drawing the picture here, if this is Sandra and she is rowing a canoe, she's going to go in one direction, and then she's going to go and come back in the opposite direction, making it a round trip. It says that this is a 10-mile round trip, which means each of these has a distance of 5 miles. All right, and then her rate, the rate for this particular one would be, and if we call this, let's say this direction, she's going against the current, which means her rate, which if it's calm would be 6 miles per hour, we'd have to subtract off the current because the current is working against us. So that rate would be 6 minus c. Coming back, we'd be going downstream. Now the current is helping you, and so our rate would be 6 plus c. In each of these situations, we also have a time for each one. They haven't said anything about the time of each individual trip, just the round trip, but we do know using this formula, if I solve for time, I could divide both sides by r, and then I know that time is equal to the distance divided by r. So this first one, our time would be 5 divided by 6 minus c. And in the second situation, going downstream, would be 5 divided by 6 plus c. And now I know that if I add these times together, so if I take 5 divided by 6 minus c plus 5 divided by 6 minus, or plus c, this should equal 3 hours, because it took her 3 hours to do the entire round trip. Now, this is a rational equation. I'm going to get rid of those fractions. I'm going to multiply both sides by 6 minus c times 6 plus c. And then doing that, in this case, my 6 minus c's would cancel. I would end up with 5 times 6 plus c. Distributing here, the 6 plus c's would cancel. I'd be left with 5 times 6 minus c. And then multiplying here, nothing's going to cancel. And if I multiply this together, if I'd FOIL that, I'm going to get 36. And I'm going to have plus 6c minus 6c. Those would cancel. I'd have 36 minus c squared. So taking that times the 3, I'd end up with 3 times 36 minus c squared. Now I would distribute. I've got 30 plus 5c plus 30 minus 5c is equal to 108 minus 3c squared. This plus 5c and minus 5c are going to cancel. This is going to equal 60. 60 is going to equal 108 minus 3c squared. I'm going to subtract that 108. So I've got negative 48 is equal to a negative 3c squared. If I divide both sides by a negative 3, I'd have c squared is equal to 16. Square root of both sides means c must be 4. Or negative 4, but our current can't be negative. So as far as the rate of the current goes, it would be 4 miles an hour. So when I went upstream against the current, my rate would have actually been 2 miles an hour. And then going upstream with the current, my rate would have been 10 miles an hour. So pretty strong current here affecting our speed and our time. So draw a picture, base it on the distance equals rate times time formula, and then write an equation. So in this particular example, again, using distance equals rate times time, it says Alicia's average speed riding her bike is 11.5 miles per hour. She takes a round trip of 40 miles. It takes her 1 hour, 20 minutes with the wind, and 2 hours, 30 minutes against the wind. How long does it take to complete the trip? So again, in this situation, I'm going one direction, I'm coming back. That round trip is 40 miles, which means each of these have a distance of 20. As far as the rate of these, her average speed is 11.5 miles per hour. So if I'm going against the wind, my rate would be 11.5 minus c. And then coming back with the wind, my rate would be 11.5 plus c. So therefore, each of these times, and with the wind, the time is 1 hour and 20 minutes, which would be 1 1/3 hours, or 1.33 hours. And then 2 hours and 30 minutes against the wind, this time would be 2.5. All right, the time should equal, again, divided by rate. So in this first situation, I've got 20 divided by 11.5 minus c, and that needs to equal 2.5. So now how do I solve this equation? I could multiply by 11.5 minus c. That would cancel. I'd have 20. Then I'd take it times 2.5. I would do my distributing. I'd have 11.5 times 2.5, which is 28.75. And then minus c times 2.5 would be a negative 2.5c. I could subtract 28.75, so I'd have negative 8.75. Do my division. And I would get c to be 3.5. Now, I only use one of these. If I do the other formula, if I take my distance divided by my rate, in this case it should equal 1.3 repeating, which I probably want to be more exact here. So instead of 1.3, 1 1/3 would be 4/3. And then I could multiply by my common denominator again, which would be 11.5 plus c times 3. So multiplying here is going to give me 60. Multiplying here, my 3's will cancel. 4 times 11.5, I believe, is 46. And 4 times c is 4c. I'm going to divide or subtract 46 from both sides, so I have 14 equals 4c, and I'm going to get c to be 3.5 again. Okay, so just showing that the current, I use c here, I should have used w for wind speed, but it wouldn't matter, I would get my w to be 3.5 miles per hour.